In this lecture, I'm going to introduce you to some of the most common and basic NumPy operations that there are, and essentially we are going to use these operations throughout the course in one form or the other. If you are rank new to Python and things like NumPy, these may sound a bit complicated to you, but I would still suggest that you run the code and preferably run it as I demonstrate on the screen. And as we go along the course, as we cover the different topics, we are going to revisit these concepts in one form or the other. So these things are going to become clear as we go on further. So now let's just get started. And before that, I'll just quickly introduce you or reiterate something. In Python, the index starts from 0, left to right, and suppose this is my NumPy array and I have P at location 1. Then the bespoke index corresponding to P is 0, and we also have negative indices, and which is the largest number, the negative of the largest number. So if I want to allude to P, I either allude to index 0 or I allude to -9. And these are some of the operations that we carry out when we want to isolate or subset or index out a part of the NumPy array. And what happens is that this is my NumPy array A. When I provide an index, a start index and an end index, the indexing will be done from the start of the bespoke index and all the way through the second last to the end. When I start, then, and if I just specify this, then it is from start to the rest of the array. End, these are items from the beginning through the second last to end, and A and semicolons within the square brackets is how we copy an array. Okay, this may just sound fairly complicated, so don't worry, we're actually going to do that in practice. I've already created a simple array A, a simple list A, and I'm going to convert it into an NP array by calling the function np.array, and I've already imported the NumPy package as np. So what I'm going to do is np.array, which turns my list into a NumPy array, and I can print out my list, and I can even print out the type. And this is a NumPy ND array, and we can print its shape, and it tells me it's a rank 1 array with 7 items, and you can see that. Now I want to print out an element at index 2. So let's just look at this figure again. And now look at the NumPy array. What do you think should be printed out? I suggest you think over it for a couple of seconds. Let's just do it. 11. Now 11, strictly speaking, in a chronological order, 11 is at the third location. It's 1 to 11. But when I specify 2, I'm essentially referring to index 2. So 1 is at index 0, 2 is at index 1, and 11 is at index 2, and 6 is at index 3, and therefore I get 11. Now I want to isolate an entire chunk based on the start index 1 and the end index is 5, and it is going to print out the values from the start index. So the value located at the start index, which is 1, and the value located at the start index 1 is 2, because at start index 0 we have 1, and it is going to print it all the way to end -1 index location. So now for the next couple of seconds, think what should be printed out. And preferably try to write it down, or not. But anyway, this is what gets printed out. It's 2, 11, 6, 8. And this is because 8 is at index 4. 0, 1, 2, 3, 4. And this is how we print out things, because when we specify the end index, what is printed out is the last digit that we get is the n minus 1 index location value. We can even use a step of 2. So I've done it. And as you can see, when we use a step of 2, we start at 1 and then we move to 6. But after that, we don't print out anything because we have come to the end. We can even have a negative index, and which will print out, or actually let us just print out the last item using -1. And this is my last item is here, and this is going to be 2, because what happens is that when we have a negative index going all the way from -7, because I have 7 items, -7 all the way to -1, then the last item in my NumPy array is the one located at -7, and that is what got printed out. Now, if I want to print out a couple of letters, a couple of digits from this NumPy array, what I'm going to do is I can specify, go from the larger index to go from the smaller index to the larger index, -7 to -4, based on this. Over here we have -9, so with a 7 item NumPy array, our index 0 is going to be -7. If I had a 10 item NumPy array, my index, the negative index of 0 would be -10, and so on. So I'm going to start with -7, go down all the way to -4, and it will only isolate numbers till -5, because in this case we move from start to end +1, and that is why we get 1 to 11. So there you are. I would suggest, it does sound a bit complicated, and I would suggest writing out an array on your own and labeling the index numbers, and then running this code a couple of times on different NumPy arrays and trying different combinations and actually quizzing yourself to see that you get the hang of it. If there was -3 in this case, we get this, because in this case we will isolate numbers till -4, and -4 is larger than -7. So we are going from small. The smallest index that we have in negative is -7, and going up all the way to -4 if we specify -3, and that's how we get values up to 6. So this does sound complicated, and unless you are using NumPy on a daily basis, this is going to sort of string you up or hamstring you in a way. So I would suggest essentially maybe even pausing the lecture and trying out a few combinations of your own. And certainly after we complete this lecture, I would recommend trying out a few combinations of your own and writing out things and drawing indices till you get a hang of it before moving on. So now items, they start at 1 index and go all the way to the end. So now if I want to start my index from, say, index 3, which is index number 3, and that should contain 0, 1, 2, 3. So from 6, that's where we are going to start from, because it's going to be index number 3. And it goes all the way to the end till 2. So in this case, the end was included. And now if I want to start at index 4 and all the way to end -1, then this is what I get. And the end is not included. And if you recall, this is how we create a copy of an array into B, and I get the same array as before. And now I can concatenate two NumPy arrays, which means I can even join two NumPy arrays containing different number of items. I mean, as long as they contain numbers, because the thing with NumPy arrays is that they have to store the same value. So if we have numbers in both x and y, and my NumPy array x has 4 numbers and y has 3 numbers, I can still concatenate them by np.concatenate, call the function concatenate and specify the package np. And when I print it, you can see I get 2684, and appended to that is 1182. And now let's quickly look at a couple of multi-dimensional array operations. And this is the multi-dimensional array that I'm working with, NARR, and you can see it here. And the thing with multi-dimensional arrays is that we have everything starting at row 0 and column 0. So the first cell is basically row 0 and column 0. So it's the same principle as before, that the Python indexing always starts from a 0. So what happens when we want to print the first row? Well, if I want to print the first row, then I am going to specify index 0 and this is how I get the first row. And now if I want to print the third row, then I have to specify index 2, and that's how we get 7, 8, 9, which is basically in the chronological order, it's ranked 3. Now if I want to print the contents of a cell where the row index is 0 and the column index is 1, so basically this is the row we are looking at, and this is the column, because both rows and columns, they start with 0. So when I print this out, we get 2. Let's just try out something else. Let us go to the second row and the fourth column. So now before I run this, I would suggest that you try to ask yourself and maybe quiz yourself what exactly should be printed out. Remember, if this is row 2, we are essentially going to move to the third row and so on. Actually, this doesn't work, so let's just try this. And we get 9, because this is at the third row. When I specify index 2, we move to the third row, and we move to the third column with index 2, and with index 3 we move to the fourth column. Since I did not have a fifth column, I got an error. So obviously if you go out of bounds, you will get an error. But the third, specifying 3 here, because we use the schema of row and column like so. So specifying 3 takes us to column number 4 in the chronological order, and that's what ultimately gets printed out. Now say I want to replace this value of 12 with 14, then obviously I ferret out which row it is. Since this is the fourth row, it is the third index, and 0 because it's the first column. Then I specify 14. So basically for this particular cell, I specified 14 for this given cell, and when I printed it out, it has been replaced with 14. And now if I want to get the last row, 2, 11, 8, 10, I just specified -1, because again we have this schema also applies for rows and columns for basically multi-dimensional arrays. So the last row is actually -1, and if I want the second last row, essentially I move up, and this is what I get. And if I want to print a given set of rows and columns, so for rows it is going to print rows from 1, the rows at index 1 to index 3, and columns at index 2 to 4. And this is what we get. So if you just compare this, let's just move up. When I specify 1, we move to row 1 over here. And that's how we get the 5 and the 9. And then column 2, again, column 2 to 4. And you can even try to draw this out. And this is what we ultimately get. Now, if we have NP arrays which end up having 2 items each, like so, we can even concatenate them row-wise by saying np.concatenate, and this is what we end up getting. So this is my row A, which is 1, 2, 3, 4. So we have the same number of columns, and if we want to concatenate row-wise, which is the easiest way of doing it, and B, which just contained 5 and 6. So this is how we concatenate by specifying, and 5 gets added to the end of this particular, added to the end of NP array A. And these are just some of the very common operations that we can carry out with NumPy. And I would recommend going over the lecture once more if things are not clear, and even making modifications to these NumPy arrays yourself and quizzing yourself as to what the answer may be, and then seeing what the answer is. And do that a couple of times and things should become clearer. And now we are going to move on to the next lecture.